Good day and a warm welcome on behalf of NTI Audio. Well, to measure the sound insulation of a partition is a quite cumbersome task. You need to execute a couple of measurements. You have to combine them in a certain way to get the results. And even worse, if you have to do that in a larger building with lots of partitions, you will very quickly see that this can become a really huge issue, a huge project, also time-wise, to complete all these measurements accurately. Consequently, it is of high interest to streamline this process to make it as efficient as possible in order to save your valuable time. And that is the topic of today's presentation. My name is Markus Becker. I'm presenting this webinar and I'm assisted by our CTO, Thomas Hupp, who is basically taking care of the incoming questions and possibly assisting us in case of any need. To the left, you see the topics that we have prepared for you. We will start with a brief overview and then dive into the best practices, the preparation of sound insulation measurements and the execution. We have also prepared a practical presentation for you. After that, we will summarize some key aspects and add some more hints and tips. I will also quickly flip over to the Sound Insulation Reporter software, which also plays an important role in this whole topic. I expect that this webinar will last about half an hour. Well, as stated in the beginning, the sound insulation needs to be measured per partition, needs to be documented in individual reports. And typically, you do not only have to qualify one partition, typically it's a couple of them. So consequently, it's worth taking a closer look at this topic. The detailed execution of a sound insulation measurement, where to position the sound source, and so on and so forth, has already been covered in a previous webinar, which you will find on our website. So we will not go too much into these details. We will rather focus on the efficiency aspect. But in order to find a common ground, I just briefly repeated or summarized the 4 key measurements that need to be executed for a sound insulation measurement. It's the sound level in the sending room that needs to be measured. L1 stands for sending room, and that typically needs to be done at several positions. That's where the N comes from. The same applies for the receiving room. Receiving room is labeled 2. So here we have the level L2 of the receiving room, again in several positions. Then we need the background noise in the receiving room, B2. And also important, the reverberation time in the receiving room, T2. Keep in mind, these are the 4 measurements that are required for each partition, to determine the sound insulation of each partition. Consequently, as stated in the beginning, it's worth to address this task with a thought-out approach in order to minimize the efforts, to minimize the time you have to spend on site for all these measurements. And to make it short, it's worth to analyze the situation upfront, to establish a reasonable plan, and then when you're on site, to reuse as many data as you can. And this is actually the focus of this presentation. To better understand that, I have drawn here a kind of a fantasy layout of a building with several rooms. So if you get the task to determine the sound insulation, the first question that needs to be answered is which partitions need to be measured, because it could be that some rooms are not of interest, some partitions. So identify the ones that you really need to analyze. Next, you can already upfront determine which is the sending and which are the receiving rooms for each partition. The rule of thumb says that the larger room is the sending room, the smaller one is the receiving room, or to say it more accurately, the quotient of the volume over the square, the area of the partition, gives us the corresponding factor that determines this decision. Consequently, room number 1 here, for instance, is the largest one. So when we talk about these two partitions, it will be the sending room, and these two ones will be receiving rooms. Same when we when we look at these two partitions, the blue ones, we have one sending room and two receiving rooms. And here we have the situation that this room, which used to be the receiving room for the previous measurements, all of a sudden becomes a sending room for this partition to this room here. You can also highlight that in colors. The yellow color, for instance, indicates that this is the receiving room for the yellow partition. The blue rooms indicate the receiving rooms for the corresponding partitions. Here we have a room which has two partitions that need to be measured, so that's double colored, purple and blue. And it is worth to note which measurements have to be executed in these rooms. So where do I have to measure the level of a sending room? Where do I have to measure the level in the receiving rooms? Where do I have to measure background noise and reverberation time? And let us look at that in more detail in a practical way. Here we have the situation where we have one sending room with two receiving rooms, two partitions, and consequently two receiving rooms. So we need to execute our measurements in a way that we start to set up the dodecahedron sound source in the sending room and measure the level therein. As stated before, at several positions, but in this drawing I just indicated one position of the dodec. Next, we would walk into the receiving rooms and measure the sound level in these two rooms while the dodec is switched on. And next step, we would measure the background noise in these rooms plus the reverberation times in the two individual rooms. And with all this data, we can now calculate the results. We can calculate the sound insulation of the two partitions. And it becomes quite obvious that this measurement here only needs to be done once. Of course, we can reuse it for the two calculations. Another example would be if we have one receiving room, the top one here, number 3, with two sending rooms because it has two partitions. So here we would start same way as we did just before with the sound level in the sending room plus the sound level in the receiving room. We would then move the dodecahedron to the second sending room, again measure the sound level in there and measure the sound level in the receiving room through the second partition. We would also need the background noise and the reverberation time in the receiving room. And this data now allows us to determine the sound insulation of these two partitions. And as you can see, a couple of these measurements had already been done in the previous example. So in this example, we could reuse the sound level from this sending room. We could reuse the corresponding receiving room level, and we can reuse the background noise and the reverberation time. These are examples how to reuse data in order to save time. Well, let me show you that in a practical example. And for that purpose, I have here an XL3 analyzer connected to my PC through a Wi-Fi connection. We are using this connect.ntiaudio.com platform, which is available free of charge for all users of an XL3. And to give you a better understanding of the layout, we have one sending room. It's a meeting room. This is next to the room in which I am sitting now. This is a so-called webinar room in which I am. And we have a third room on the opposite side of this meeting room. This is the so-called photo room. And there we are taking some photos of our products, for instance. I'm also using some accessories, some additional equipment to do the measurements, especially the dodecahedron, sound source, and the delta clapper. You're going to see that just in a second as soon as I flip over to the next layout here. I will now activate my webcam. And the screen content of the XL3. So here you see not only the screen content of the XL3 that is here sitting on my desk, you see it here, by the way, hello, that's me. You can also remote control the XL3 through this link. If you look through the window in the door, you see the dodecahedron sound source in the next room, in the meeting room. And if you look a little bit further even, you might see the spotlights hanging from the ceiling in the so-called photo room. So let's start with the setup of the XL3. For this purpose, I click on this icon. I can see here the standard that has been selected. I will come back to that later. We have the airborne noise measurement, one source position, and here I could now edit the duration of my measurements. 15 seconds is typical, but for the sake of saving time, I'm going to 6 seconds in my presentation. I could also decide whether I want to base my reverberation time measurement on a T30 or a T20 analysis. I stay with the T20. And this is the minimum trigger level that needs to be exceeded so that the instrument starts a RT60 measurement. You're going to see that just as soon as I do that. Well, go back to this screen and start partition. Here I could now change the choice of my standard. You see we have 3 standards implemented. More will follow very soon. We are working hard on that. We can select whether we want to do an airborne noise measurement or impact or even facade. All 3 are supported by the XL3. I could also decide whether I will do more source positions, but I stick to 1 here. And here I could edit the name of my partition. It's important to use a unique name so that you will find this measurement result later, that you will be able to identify what you did. So meeting room to webinar room, confirm, okay. Now by clicking here on this button, we can select with which measurement we want to start. And actually I want to start with the level in the source room. That's what I have selected here. And I have now to put my XL3 in the next room, and then I will start my measurement. Well, you will see it on the screen. I will switch on my dodecahedron and then start the measurement on the XL3, which is now located in the sending room. Maybe you noticed here, bottom left corner, that is the countdown, 6 seconds. That was the duration of the measurement. And if you look at the screen, you see the yellow bars. This is the measured result, the sound level in the sending room during these 6 seconds. So we click on here, we can see, well, 1 measurement has been executed. If I would repeat the measurement, it would count up 2, 3, 4, and so on and so forth. But I will make it short. I go over to the next measurement, the level in the receiving room. And for that purpose, of course, I have to bring my XL3 back to this room. Doing the same as before, start the dodecahedron and then the measurement. Maybe you heard the noise in the background, pink noise. Anyway, here you see the yellow bars are now the level in the receiving room. That's the result. Next step, background noise in the receiving room. So I will be silent for a couple of seconds and start the measurement, of course, without Dudik. Well, I also have this data. Now the only thing is missing, the T2, the reverberation time in the receiving room. And I'm going to show you that as well. It's the most spectacular measurement, actually. You're going to see it. First of all, I will later click here on the start button. Start means that the device, the XL3, is now ready to wait for a loud incident, be it pink noise, be it a big bang, the one that I'm going to create with my clapper, and then trigger to it and measure the reverberation time. And I can redo that. I can record several cycles. You're going to see that. If I'm not sure about how loud my noise must be, I can click on this entry here, set level markers, and that tells me the minimum level. You see it here, these gray bars that show me that versus the silent room, this is the minimum level that needs to be created here in my room in order to execute a reverberation time measurement. So let me click on start and then do these. I'm going to do 3 cycles of an RT60 measurement. Well, I guess you've seen these ticks up here. They indicate that all these bands have been measured successfully. We got individual results for each band. Here we see the counter for the number of decays that we have measured, that we have analyzed. And by just swiping over the screen or clicking on this button, you're going to see here, this is the individual results. So these are the reverberation times for each band. And we also can see the numeric results if you're interested in that. So this is now my T2 result. So I have everything that I need. In practice, I needed to execute a few more measurements or repeat the measurements, but here for the presentation, that's enough. And now I can take a look at the results. For instance, the level difference D. One more important hint, down here you see the geometrical dimensions of the source room and this receiving room and of the common area. Well, 17 meter is correct, this one as well, but in reality my receiving room is a little bit larger, so I can edit that. I go to 62 cubicle meters and then the result will be immediately calculated correctly. This is, as I said, the level difference. I can also look at it in a graphical way. I can take a look at the normalized level difference or the standardized level difference, or last but not least, the apparent sound reduction index. So looking at these results already on the device itself allows you to get important feedback. Is my sound insulation good enough? Does it meet the requirements? Do I have to improve anything in the sound insulation to make my customer happy? Well, let's assume we are finished. We end this partition. The data will be saved on the instruments. And now I want to show you another example. Let's say I would want to step over to the next room, to the photo room, as I stated. But rather than redoing all these measurements, actually I have prepared them. I save them here under this folder, Meet Room versus Photo Room. I resume my project. And if I look here on the data, you see I have already recorded the level in the receiving room, the background noise, and the reverberation time. What is missing is the level from the source room. I could now redo the measurement, but that's not necessary because I can import this data. So I click on import, and here you see Meet Room, Webinar Room. Because the Meet Room is the same source room, there is an L1 result. Click on it, import it, and I have the data. That's very easy. So this is another nice example how we can reuse data. And again, I can look at the individual results, the level difference, and so on and so forth, the same way as I did, as I showed you before. Good. So we have done these measurements, and we can now step further for the in-depth analysis, which I will show you just in a minute. But first, let me get back to my standard presentation. And summarize the key points. Keep in mind, it's worth, if you have upfront information of the location where you have to measure, take a look at the plan, analyze it, make a rough plan how to proceed. That can help you a lot to save time on the on-site. And also keep in mind, especially for the post-processing, it's really worth to think a little bit about the naming of these partitions in order to identify them in a unique way so that you easily find them if you look for them. And we recommend, for instance, to use the name of the sending room and or the source room and of the receiving room one after the other. That gives a clear indication what you have measured, which partition and from where to where. Talking about time saving, the Delta Clapper is a really nice tool when it comes to reverberation time measurement. You have seen that. Keep in mind, in some countries, it is not allowed. The standard does not allow to use a Delta Clapper for the reverberation time measurement. This is something that you have to find out in your country. The dodecahedron is, of course, always a valuable source for reverberation time measurements. The XL3 can cope with both signals, with the bang from the Delta Clapper as well as the pink noise from the dodecahedron. But if you have the choice, the Delta Clapper is really a nice solution to save time. Not to forget, in this presentation, I have concentrated only on airborne noise sound insulation, but I guess you know that there's also impact noise that may need to be measured. If you have to do an impact noise analysis, you need a corresponding sound source. And actually, there are two choices you have, either the tapping machine or the so-called impact ball. Both of them are standardized. You can get them from us. The impact ball has the advantage it's easier to handle. You just have to drop it from 1 meter height to the floor in the room above the measurement instrument. It works very well in wooden buildings, for instance. If you are in a very solid, very well isolated building, concrete building, then it might be not enough to use the impact ball because it's not coming through the sound that is created by the impact ball. And if you have ever listened to a tapping machine, I guess you know that this creates really a very loud noise, a clear noise that can be measured much easier. But as I said, in wooden buildings, the impact ball is a very nice choice. And maybe the most important tip, share or reuse as many measurement results as possible. Sound level in the sending room, sound level in the source room, or background noise in the receiving room, reverberation time in the receiving room. These are the measurements that you can, in most cases, reuse for various partitions. And that is worth to note in advance, just in order to avoid that you have to redo a measurement because you forgot something. But reusing these measurement results is maybe the most efficient way to cut down the time you have to spend on site. Last but not least, the Sound Insulation Reporter software is also a very helpful tool to gather data, to visualize it, and to post-process it. I'm going to show you that just in a second in a very brief way. and also to give you the hint that you can also execute one measurement in several rooms at a time if you are one of the lucky guys who has more than one XL3 available. So this is the typical screen of a sound installation reporter software. And let me briefly flip over to the software itself that you can see it. I will not spend too much time on it because we also already had a webinar on that, but just to re-show it to you, here you see I have imported the measurement data from an XL3 with more measurements. So I executed my analysis always on several positions. What you can see here, you see the labeling, sound level, source room, position 1, position 2. So everything is nicely labeled. You have here the auxiliary information, where this has happened, what was the volume, the area of the partition, the volume of the source in the receiving room. You can also take a look at the individual calculations, the averages here. You can take a look at the results. You can even edit if you want. You can click on a specific data. You can delete it if you don't like it, whatever. And the software will provide this standardized reports. And this is the item that you're most interested in, because this is the document you can sell to your customer. This is the document that proves you have done a correct job. The sound insulation is within the limits or whatever. So that is what the software provides as well. It is partially editable. You can exchange the logo here. You can add some comments, but the important part is standardized, and that is replicated in this software. Okay, get back to my presentation. As stated, you can remote control several XL3s from this software. You can do the post-processing and create the standardized reports. Well, that brings me to the end of this presentation. Me from my side, thank you very much for your attention. I hope you appreciated the presentation, and would be very happy to welcome you again at one of our future webinars. For the time being, have a good time, stay healthy, thank you, and bye-bye.